So the third question says find two distinct square roots of I. So we are asked to find the square roots of I. For this, what I can do is multiply and divide I. Here the value will not change. Then what I can do is add plus 1 and subtract 1. Even here the value does not change. Then I can write minus 1 as I square. So this will be 1 plus 2I plus I square, because I square is minus 1 by 2. Then this will become, this is of the form a plus b the whole square. So if a is I and b is 1, then this is what I'll get. So now I'll get plus or minus I plus 1 by root 2. Therefore the two distinct square roots of I are plus I plus 1 by root 2 and minus of I plus 1 by root 2. Moving on, the fourth question says that show that alpha plus beta equals beta plus alpha, where alpha and beta belongs to complex numbers. Because alpha and beta are complex numbers, what I'll try to do is write it in the standard form. Let alpha be x plus iy and beta be z plus iw. So alpha plus beta will be x plus iy plus z plus iw. According to the addition of complex numbers, I have to add the real parts together and the imaginary parts together, and I'll get this. Now let this be equation 1. Now beta plus alpha is nothing but z plus iw plus x plus iy. Here again add the real parts first and then the imaginary parts, and this is 2. Because addition is commutative, x plus z and z plus x mean the same. So that is why alpha plus beta equals to beta plus alpha for all alpha and beta in complex numbers. The next problem is very similar to this, where show that alpha plus beta plus gamma equals to alpha plus beta plus gamma. Here again, take alpha to be x plus iy, beta to be x1 plus iy1. You can take alpha as x1 plus iy1, beta as x2 plus iy2, and gamma as x3 plus iy3. For first calculate alpha plus beta plus gamma, this will be equation 1. Then calculate alpha plus beta plus gamma, this will be equation 2. Compare and it will be the same thing. Next is the sixth question. Show that alpha beta gamma equals alpha into beta gamma. Here also the same technique is used. This will be a tiring calculation. You have to do it a lot, but the concept remains the same. Choose alpha as x1 plus iy1, beta as x2 plus iy2, and gamma as x3 plus iy3. And first solve alpha beta gamma. This will be equation 1. Then calculate alpha into beta gamma, this will be equation 2, and compare and it will be the same thing. Next question says, show that for every alpha belongs to C, there exists a unique beta in C such that alpha plus beta equals to 0. So here again, what I'm going to do is choose alpha to be x1 plus iy1 and beta to be x2 plus iy2, where x1, x2, y1 and y2 are belongs to real numbers. So what are they saying? If alpha plus beta is 0, then x1 plus iy1 plus x2 plus iy2 is 0. So adding the real parts together and the imaginary parts together, I'll get x1 plus x2 plus I times y1 plus y2 is 0. So this 0 can be 0 plus I0. So equating the real and the imaginary part, I'll get x1 plus x2 is 0 and y1 plus y2 is 0. So that means x1 is minus x2 and y1 is minus y2. Sorry, I have to find beta. So x2 is minus x1 and y2 is minus y1. So this implies uniqueness. And if beta equals to minus x1 minus I y1, we will have alpha plus beta is equals to 0, which implies existence. Moving on to the next question. Show that for every alpha belongs to C with alpha not 0, there exists a unique beta in C such that alpha beta is 1. So here what we can do is beta equals to, I can write beta as 1 into beta, and 1 can be written as 1 by alpha into beta, which is 1 by alpha into beta. Alpha into beta is given as 1, so this will be 1 by alpha. So therefore beta equals to 1 by alpha. In the ninth one, show that lambda times alpha plus beta equals to lambda alpha plus lambda beta for all lambda alpha beta in C. Again here, what we can choose is lambda to be some constant a plus ib, alpha to be x1 plus iy1, beta to be x2 plus iy2. Then first calculate lambda times alpha plus beta. This will be equation 1. Then find lambda alpha, lambda beta. This will be equation 2. Compare these two equations and you'll have the same answer. Moving on, find x in r to the power 4 such that 4, minus 3, 1, 7 plus 2x equals to 5, 9, minus 6, 8. So here, to find such an x, first what I can do is 2x equals to 5, 9, minus 6, what is that number? 8, minus, take it there, 4, minus 3, 1, 7. So 2x will become 5 minus 4, 1, 9, minus of minus 3, 11, minus 6 minus 1, minus 7, 8 minus 7, 1. So x will be 1 by 2, 11 by 2, minus 7 by 2 and 1 by 2. So this obviously belongs to r to the power 4.